Good afternoon, everybody, and I welcome you all for the current session of Internet of Things, in which the theme is research directions. And as you probably know that we have been delivering a series of lectures, webinars on this Internet of Things topic. And in one of the first sessions, we talked about the general introduction to IoT, what does it actually consist of. And in the second session, we actually talked about an architecture called web-based architecture for the conduction of this Internet of Things phenomenon. Followed by that, we actually answered the crucial questions of security and privacy in the second session called Will IoT be secure enough? In following that, actually, we covered one of the important areas actually where applications of the IoT can be found. For example, IoT is a solution in search of a problem. No matter which area of life we are dealing with, IoT has some or the other solution for you. So once that is done, actually, now it is pertinent to look into the next aspect, that is research directions in IoT. That means IoT is a growing area. So it has its own growth rate, and it also has obstacles and challenges. These research areas is actually identified in this particular session. So this session number 4 is all about research directions in IoT. So the agenda I have is very simple, a brief survey of research domains pertaining to IoT. So IoT is actually amalgamation of many sciences, many technologies. It's not an isolated technology. So because of this, there is a multidisciplinary approach and multi-engineering approach to devise solutions to overcome the obstacles. So that I will be covering. And I will be briefly asking this question, why IoT needs research? Why do we need to conduct any research in the IoT area? Once that is answered, then what are the current research areas identified? Different groups, different governments and different research organizations have been working on this, and they have found their own areas which is important to conduct research so that actually they can enable IoT to happen. And finally, what are the future trends? So it's expected that IoT is going to be an integral part of our future life. And what are the trends and corresponding research challenges? So let me start with the basics of Internet. So before Internet of Things. So before actually we fix a research agenda, we should know the nature of what is the IoT all about. Once we know what is the nature of this, what are the components involved in this, what is their characteristics, what are we expecting to do from IoT, then we can actually fix our research agenda. Hence, I start with the basics. See, the IoT is a new world order. So what is IoT is all about? The use of Internet as a global platform for letting devices, machines and smart objects to communicate, dialogue, compute and coordinate is unleashing a new world order. So that means we are creating a new order. How do we create? We are allowing the existing Internet so that devices can talk to each other, that is they can communicate, they can have a dialogue, that means they can keep exchanging information and conversation they can conduct, and they can also compute, that means if they sense some information that can be computed so that they can make a decision, and also they coordinate. 2 or more IoT devices can share information and coordinate. So this is creating a new world order. So existing Internet, which is used to connect people, computers, is being actually used to connect devices. And these devices can do 4 things, that they can communicate with each other, they can conduct a dialogue within and among themselves, they can compute using the processing power they have, and they can also coordinate certain activities. So this is creating a new world order. So because of this, that means I am adding a thing to this Internet to make this Internet of Things. So in order to include one thing, I need 3 things. That means these things are, everything that I add should be identifiable. That means if I add a sensor, that must have some kind of addressing mechanism. Normally we use an IP address. So the first thing, that any identifiable, anything that is added must be identifiable. Okay, it could be a sensor, it could be a mobile, whatever it is, but it should be identifiable. And it should be capable of communicating with others. That means if I add one thing to the part of IoT, it must be able to communicate, it can talk to another device. And thirdly, they should interact with each other. That means 2 devices which are connected to Internet, making a part of the IoT, they must be able to talk to each other. While doing this, actually, they are identifiable. That means among themselves, 2 IoT devices must be able to identify themselves among them, between them. And they should be building network of those things. For example, 10 sensors should build a network of their own to coordinate certain activities. And they also should be in a position to talk to the end user. That means if I install about 10 sensors in my lab, they should finally be under the manager or some kind of a researcher who is actually conducting that research. So that means IoT has an idea of actually establishing a network where I am adding things. These things can be identified, they can talk to each other, and they can interact with each other. So because of that, that means now there's a new trend of adding things to internet. It is predictable that in the coming decade, that means now that I'm able to add sensors to the networks, the internet will exist as a seamless fabric of classic networks and networked objects. What do we mean by classic networks? As of now, until very few years, actually internet was meant to connect PCs and other devices, and it was the users were always individual people. That is called classic network. But I'm creating a next kind of a network of objects. So that means instead of people, I'm connecting objects. Over a period of time, what would happen according to this prediction is that in 10 years down the line, so internet would be having two components. One is actually the network of people and network of objects. But this is actually connected in such a fashion that you don't find a difference. Anybody who is about 40-45 years will realize that when actually mobile was introduced in India or anywhere in India, see, it was not possible to make a landline call from, you cannot use a landline to make a call to mobile device. But now you cannot make it differentiate whether you are receiving a call from a landline or a mobile. So this kind of integration happened over a period of time. So now mobiles are as good as the landline phones. Similarly, over 10 years of time, what would happen is the current traditional internet which connects people will be meshed with the network which is created by the objects. So once this world is created, whereas thousands of billions of things are connected, the content and service will be coming around us. For example, once internet was created, there was a lot of content. In order to search this content and to organize this, a company like Google was created, right? Similarly, in order to connect people, a service like Facebook was created. Similarly, when more and more and thousands of things get connected, there will be new content regarding the nature and the population of such devices, and services will be built to discover them, to identify them, to communicate with them. This will be having. So once this happens, then that would create a new world order where actually it will create new kind of application. For example, since internet was created, web is existing, we have something services like software as a service were meant for the people. Now in the IoT, you may have a services or applications which are meant for these IoT devices. Or new ways of working. It is possible that since you can get connected to your workplace through internet and you can control the devices installed in your office in such a fashion that you can work from the home. So there are different ways of working and new ways of interacting. What it means is actually now you can connect to your device like a fridge or a mobile or a TV in a more controlled fashion using your mobile. And also you will have entertainments and new ways of living. For example, if you are an aged person, then there are assistants which will be given by this IoT. So then the question comes like, what does this IoT consist of? So it will be consisting of extended internet technologies. That means today's technology connect people. The extended technology will also connect objects. Then there will be a set of supporting technology. For example, when I install or add an IoT device to that, means I want to have additional protocols to connect them, speak to them, all those things will be there. And there will be a group of applications which are meant both meant for this IoT themselves and IoT among themselves, and also to connect those to the people. So because of this, I have a challenge on my hand. So my vision is to connect everything in the world, give address to each one. So developing technologies and solutions for enabling such a vision. What is that vision? Now that I have connected people using internet, I will be connecting every item in the world, whether it's man-made or natural, to the internet. So that is my vision. So the challenge is to develop technology and solutions to create that kind of a world order. Okay. So the central idea of this is very simple. The key idea behind Internet of Things is research the potential of embedding computing and communication capabilities into every object of common use. Now that I have a phone, traditional phone, which has no IoT capabilities. I have a pen which doesn't have an IoT capability. So the first objective of IoT is to embed computing and communication capabilities to my pen or my pencil or my mobile or my cell. So that's the first thing. And hence we need to account for the following. That means if I add one more device to internet, how do I identify it? And how does this device sense and actuate? What it means is, now I have a sensor installed, then how does it sense the environment? That's the first question. And suppose I sensed and I want to take an action, how does it take the action? So the central idea is that put computer and communication device into everything around us, whether it's a human-made machine or it is a natural device like a plant and all. So any question at this point of time, Sridhar?
No, sir.
I'll proceed?
Yes, sir.
Okay. So now that I have establish the context. That means we are going to create a new order where objects will be connected and they are capable of talking to each other, communicating with each other, and interacting with each other, and finally sensing the environment and also acting upon the environment. Now I should define my research agenda. That is what I'm going to do now. Okay, so there are broadly about 13 areas of identified areas where actually research can happen, and let me start. The first one is identification technology. So the first requirement, as I told you, IoT world is created by adding devices to the network. So before I add a device, I must be able to identify it and say that this is so and so, whether it's a sensor or not, whether it's a medical device or not. So you need a different technology to implement this. So secondly, we also need an architecture. Architecture is, for example, today's internet works on some kind of a OSI protocols, right? Similarly, I want to create a new world where actually I connect things. For this need an architecture. So architecture is actually a broad-based mechanism where actually some central principles like protocol will work. And I have covered this in my second session. Okay, you can always go back to and see that one. And communication technology. Now actually in internet we talk through our phones, our computers and all. Now in a world where things are connected, I need to develop a technology where a thing can talk to another thing. For example, phone can directly talk to a phone, or a computer can talk to a fridge. Okay, that I have to do it. And the networking technology. Today's networking technologies are meant to connect only computers, and now we want to connect all the sensors, we want to connect all IoT devices. That also need to be developed. See, once the network happens, then things get connected. Then in order to devise a mechanism so that who is where, for example, which of my devices is where, which of my person is where, you need what is known as discovery mechanism. For example, in a particular town, how do you find whether somebody is there or not? There is a yellow pages in that city. Similarly, internet, how do you find? Service-oriented architecture has something called discovery mechanism where you can discover a service. Similarly, in an IoT, you must be able to identify or discover an item. So that for that you have network discovery. And you know, today everything is software. So we don't want to do work, we want programs to do them. So similarly, we have been developing applications for the human end using. Now we want to develop where actually machine can use those softwares and algorithms, and also we need hardware. And we also other technologies like data and signal processing technologies, because see, the reason is actually data, a lot of data is generated because every time you sense, you collect data. And signal processing is because all these devices are connected using wireless. And wireless is all about processing and signals. And discovery in search engine technologies. See, today search engines like Google or Yahoo are able to find out the information which is given by or created by people using an HTML technology and all. But tomorrow we need some search engines which are able to search for themselves. For example, an IoT can use that search engine to identify another IoT in the connected. And we also need power and energy storage technologies. Today, our computers are actually have a lot of redundant power. For example, we always have a stationary computer with charge. But when we actually installing an IoT, say in a garden or in a lab and all, we may not have this kind of a robust support of power technologies. Say, for example, in a lab or say, suppose in a ground or in a garden, you cannot have a current continuous power supply. So we need new technologies which will meet the power requirements of this. And we also talked about the security and privacy technologies. Now that more and more items will actually, things are connected, and this item belongs to some people and who have either used that to share their information and all, how do I guarantee that security? And any additional information actually was covered in my session number 3. And the standardization. So standardization is a very important thing. It actually started with industrialization, where actually replaceable spare parts actually created a lot of advantages for the end users. For example, if if one of my electric bulb actually goes down, I can actually buy it from different vendors like a Philips bulb and all. Why is it possible? Because all companies will actually follow the same standards. So these are the 13 areas where actually IoT research has a potential to happen. Let me show you a picture which actually shows this one. So the taxonomy of research areas in IoT, if you can see it actually on the left side, you see a security mechanism, security domain, where we want to develop a trusted platforms. That means users must be encouraged to come there, because they shouldn't feel that if I use an IoT or if I share my information using an IoT, I would lose my privacy and all. That should not happen. Low complexity encryption. See, to encrypt you need a lot of computing power, but you cannot expect these sensor devices to have that kind of a power and use that for encryption. So you need a low complexity encryption. Similarly, access control. Today, our computers are actually protected using a personal computing code like password and all. But these sensors and all, actually, they are located in different locations. How do I control the access control to them? That is there. Say other things like confidentiality. And we also have in the middle 3 different areas. For example, distributed intelligence, distributed systems, and distributed communication. So what is this distributed intelligence? This is actually using processing of information to get insights and using that insight to convert into an intelligent action. So you can see on the right side data representation, reasoning, all those things. And finally, computing and communication, which actually is used to connect 2 or more devices. So essentially, this is what the field of research which is the distributed intelligence, distributed computing, and on the right side you can see many areas. Okay. So let me start with the first technology. So this is how my presentation will go. So I will pick up one of these 13 features which is research oriented. I will speak about in a 1 or 2 slide what is the theme of that particular area. Then I will list the research challenges which are being faced and which are the research tasks which is already underway. Number 1 is identity technology. This is technology all about identifying an item which is added to a network. That means a thing is need to be added to create an IoT, and how do I identify? So there are schemes, global ID schemes, like across platform. A device can be connected to a network and it can be accessed from where. Identity management, like our management, and identity encoding and encryption. That means how do I protect this one by encoding it? Pseudonymity is actually, suppose a real person wants to participate but he doesn't want to reveal his identity. Now there is a mechanism called pseudonymity where actually it will help you that you are a real person but your actual identities are not disclosed. And we also need revocable anonymity. That means if something goes wrong or if you want to find out who was this anonymous person, there are technologies which are available. Authentication of parties. How do I know that a correct person is actually accessing? For example, if you are conducting an examination, then you should authenticate that it is the right candidate who is writing the examination. There is no impersonation. Okay. So similarly, creation of global directory to look up services means actually I must find globally, like see which company is offering which IoT service. So essentially, IoT is all, identification is all about adding an item, giving an address, and building a directory of those items so that a user can actually find out them. The second important thing is architecture. Now that I have identified, I have to organize them on a global scale. So I cannot go and randomly organize them. I need to have some kind of a framework, and that is called architecture. So the question that I would actually, how will these things interact in across applications? Millions of billions of items, how do they interact with each other? For example, how does an IoT device installed in my college can interact with a device which is installed in IIT Mumbai? Or how does it actually, an IoT device installed on a street light can interact with the power station elsewhere? So these questions should be asked. And actually I have covered this in this second session of my presentation, way back, that you can see. Often devices need to be connected and share data across they need. For example, and a sensor would like to connect to another one. How do you protect? That means how do you share data but while actually protecting it? That's the second question. So architecture is the second fundamental research area. You ask a fundamental question that now that the billions of items are there, how do I connect them? So this will lead to the research areas like design of distributed open architecture with end-to-end characteristics. What it means is, if I install one sensor or an IoT device in my college, and if I want to connect that to one device, say in Sri Lanka, how do I have an open architecture where it has to pass through all these barriers of networks and all, and finally be compatible with them? Okay. And the third one is neutral access. Today there is a big furor in the business as well as in political things about net neutrality. That means how do I make all makes and all products of all companies equally recognized and respected in an environment? I don't want to distinguish between say Microsoft product and a Linux product. So this is called net neutrality. That is also applicable to IoT. So what are the research questions in this Internet of Things architecture? Decentralized automatic architecture based on the pairing of nodes. See, I cannot have a central authority in an IoT. The reason why actually Internet today is very famous or very powerful or very accepted because it is an open architecture and decentralized. That means each node can manage itself. So similar approach will also be taken in case of an IoT. Architecture moving intelligence, it's the very edge of the network up to user terminals and things. See, today we have a model of computing called cloud computing, which is actually central in nature. That means everything is centralized and stored in data center. But there are applications where actually you don't have to store data in a central, which is data center, which is miles and miles away or even across the continent. So there's another technology called fog computing. What fog computing is this? So you store all your required data or whatever that is needed resources on the edge of the network. That means you don't go out of your home, out of your town, out of your country to keep your data. So that's called fog computing, and this is also called edge computing. And finally, use market mechanism for the increased competition and participation. That means if you allow more and more people to participate, more and more innovation will come. So if you keep your mechanisms open, that will help a lot. So now that I have identified them, now that I have second case is actually having an architecture, the third thing I have to take care is actually communication technology. That means how does two IoT devices will talk to each other. In the IoT, a range of connectivity options will increase exponentially. That means a sensor will talk to a sensor will talk to a fridge, a sensor will talk to a manufacturer, and so on. So in this context, the communication needs will change, and new radio and service architecture will be required to cater to the connectivity demands. See, because of the frequency and all, I need a different kind of a radio mechanism, like FM radio and all, which is there for human interaction and publication. We need a different kind of a radio communication technology. So this is another point of time where actually I can open for your questions. So, are there any questions? Sridhar? Hello? Hello, Sridhar? Hello? Sridhar?
Yes, sir.
Hello? Sir, any questions?
No questions, sir.
I'll proceed?
Yes, sir.
Okay. So if you're talking about communication technology, these are the issues to be answered. Internet of Things, energy efficient communication is needed. See, any human used computer like laptop and all, they consume lot of computing power. This kind of a power is not needed by IoT devices. So they have to be energy efficient. Second problem with IoT is they are spread across this space. It is not necessarily that like a computer, they are within a building or within a wireless network. They could be in remote areas and all. So you cannot expect a constant regular power supply to them. So you have to develop different mechanism so that whatever the power available, they should use it efficiently. And secondly, they need to use software defined radios. What it actually means is, see, today much of the mechanisms, for example, in the network and all, hopping tables and all, they happen actually under a particular manual operation. Whereas in a software defined process, actually a software will be sitting above and that will decide and make most of the decision. Similarly, we want to use these IoT devices to be controlled by a software. Connectionless communications. See, for example, suppose somebody is operating at the edge of a network which is beyond the internet, beyond the wireless network of a network, then also we should be in a position to connect them. And secondly, communication to enable information exchange between things and internet. See, today we have protocols like sending email or texting that actually goes between two people. Now we also have to develop a mechanism where actually I can connect, a thing can communicate with another by sharing an information. And these are capable of collecting information on a sensor. What it means is, suppose I have installed a medical device on a patient. If it senses some kind of a variation, this must be capable of sending information either to a doctor or to a hospital or to a caretaker. Okay, so that is a part of the challenge in communication technology. And communication with actuators. What it actually see, there are two components to any IoT. One is called sensing. That means it will actually sense what is happening in the environment. For example, if you have a sensor which is meant for measuring the temperature in the environment, it will measure the temperature. Similarly, if you have a sensor installed in your car tire, it will actually measure the pressure of that. Similarly, if you have installed a sensor in your engine, that will measure the temperature of that. So that's called sensor. See, IoT is not only limited to sense the environment. It is also meant to take action based on whatever you have sensed. Say, for example, if the pressure in the tire is less than what is needed, then actually there must be a second mechanism to tell it to the owner, saying that now kindly stop your car, otherwise you will actually damage your tire. So this kind of a mechanism which will help you to take an action based on what you said is called actuator. That is also part of this one. Look at this communication with actuator to perform actions in the physical world triggered in the digital world. That means I look at a particular temperature and decide I should not water my garden today. And I sense a particular low pressure in my tire and decide not to travel any further. So this kind of a mechanism called as actuator. Communication technology for localization and tracking physical world location determination and tracking. For example, if you are using the sensors to control a traffic within a village or within a campus or within a particular town, and these devices must be capable of localizing them and actually sharing that information. So now that I have communicated, then I have to develop a network of things which can communicate with each other. So number one, I identified. Number two, I built an architecture. Number three, I made them capable of communicating. Now I will move on to the network technology. For IoT vision to be realized, the Internet of Things actually needs to be built upon the top of the existing network. So I don't want to build a grand new different infrastructure for conducting IoT. I will be using the existing Internet for that. Wireless network technologies have gained more focus due to their ability to provide unobtrusive wireless communication. That means because that advantage is there, so you don't have to physically lay a cable. So a wireless technology will help you a lot. So the question that I'm asking now is, how do I build a network so that I connect? I'm using the existing internet and the wireless network. One of the challenges that we actually has to manage is actually chip communication architecture. That means now instead of making networks or nodes capable, we want to make chip themselves capable of talking to each other. Thirdly, we want to build a network components which are power aware. That means if they are installed in a remote area like Himalayas or in a jungle or in a remote place, then they should be aware and they should be capable of switching on and off accordingly. For example, today on our computer we have a screensaver. So if the user doesn't use it for quite some time, a few minutes, then it get off and you see a screensaver, right? Some kind of a mechanism also should be built into this kind of a network where actually power can be saved for reasons, because power is always scarce. And next we have to also have this scalable communication infrastructure. That means if I add 10 sensors today, they should be working. If I add another 1,000 sensors immediately, instantly, they should be able. So scalability is also an issue which is actually met in the internet by cloud computing features. Now we also want that features to be included in this network technology. And these are the research areas where actually network technology is working. Network technologies, fixed, wireless and mobile. So I would like to use IoT installed on a fixed network, on a wireless network and a mobile network. Ad hoc and wireless sensor networks. For example, now we know that there is an earthquake in Nepal, and we also know that the remote areas of Nepal where actually communications lines are not built. Now, is it possible to use some kind of IoT devices to go there and serve? In that case, actually we develop what is known as ad hoc wireless networking. Autonomic computing is one where actually a computing devices have the freedom to make a decision. And we also have this IP and post-IP technologies. For example, IP technology give you an IP address so that I can access. But now there are technologies which gone beyond this and develop different mechanisms so that actually you can still get connected even outside the network. So interaction time. Any questions at this point of time?
Yes, sir.
Sridhar?
Is pseudonymity equal to IP address?
What is that, sir?
Pseudonymity equal to IP address.
No, sir. Pseudonymity is actually a mechanism in which a person is able to participate in an activity without revealing his real identity. Say, for example, assume that there is a web forum where somebody is participating and he wants to give his opinion, but he don't want to divulge his actual identity. For example, suppose there is a discussion on should there be a penalty, capital punishment for a crime, should he be hanged. So suppose somebody is participating, assume that he is a judge, working judge, and he want to give his opinion but don't want to reveal his identity, then he can use what is known as anonymous or pseudonymity, where actually he is a real thing but his real identities are not revealed. Similarly, in IoT, a device can participate, contribute without divulging its identity. So that is called pseudonymity. It's not IP address. It is an existing thing whose actual address, actual identities are not known for some purpose.
Is the access for fog edge computing same as for cloud computing?
No, sir. Cloud computing is actually centralized and stored in data centers, where actually fog computing is all about at the edge of your network. For example, if there is a regular information that you always need for your college, then you don't put it on cloud because that is too far to go every time and coming, because it will cost you bandwidth. So this, which is at the edge of your college network, is called fog computing. So fog computing is actually the opposite of cloud computing, where actually instead of putting everything on a data center and go every time to get it and fetch it, you actually localize and store it on a particular server, which is localized at your place. That's called fog computing.
Will each appliance have an IP type?
IP?
Type.
IP type means? I don't know. But actually, see, ideally every appliance, every identity, every item that is included into the IoT will have an IP address which is unique and can be traceable.
Why do we need open architecture for IoT?
Very simple actually. See, today internet is successful because it has an open architecture. See, before internet came, actually much of the things were not possible because they were closed architecture. What it actually means is, see, suppose you are developing an application for Linux, it will work only on that one. So if you are developing on Microsoft, it will only work on Microsoft. That means there were silos. That means what works on Microsoft will not work. So how did they solve this? Actually, by developing an OSI layer and application layer, what they did, they made it open. What it means, one application talks to another application seamlessly because both of them actually follow the same standard. So open access, open architecture will help so that sources and products can talk to each other. One application staying on one banking web server can talk to another application elsewhere in another banking one. That's one thing. Secondly, user can migrate from application to application easily. So what it actually means is, so today we have what is known MNP for mobile now, mobile number portability. Why does this happen? Because all the mobile developers, they use that open standard. So migrating from one service provider to another service provider is very simple and straightforward because there is an open architecture. So that would actually increase the option for the user, and it will also increase innovation chances so that there will be a fair competition in the market. So whatever true and whatever made internet successful because of its open architecture will also make IoT possible, successful if it is an open architecture.
And no more questions.
I'll go. So the next one is actually software service and algorithms. We know that everything in today is actually has a computing, and one of the best way to control computing is actually the programming. So now we need software service and algorithms which will manage everything related to IoT. For example, I need an algorithm to configure all the sensors in my college, or I also need a service to see the health of all those components which are there. So this software, that novel applications and interactions are realized. For example, a software to count all the IoT devices in my college, their health, their status, what is actually they are doing. That is I need. And for the manageability, the need of some sort of self-configuration. See, now that there are millions of nets, it is humanly impossible for us to actually go to each one of the device and manage them. So we need a self-configuration. That means if I do something at a central localization, as a server level, then all the machines should actually get it updated. And they should be in a position to auto-recover. See, I cannot go to a sensor which is installed in a remote garden or a remote place like Himalayas to repair every time. They should have some kind of a quality. So this is built using a particular software. And I told you, so this kind of a software will help you to execute in a remote location. For example, no, it's not only like Himalayas. Suppose you have installed when you have sending a satellite like ISRO satellite and all. So in that case, actually IoT devices will help you to manage those things from a remote location. So for that you need a software and algorithm which is robust in nature. So what are the research areas which are open in this? Number one is service discovery and composition. Now that millions of services are available, how does an IoT device will identify a service and discover it and get it? It is something similar to, I told you, yellow pages in a bank, in a telephone directory. So suppose you are new to a town, then normally use a yellow pages to discover a new service provider, right? Similarly, this is discovery. Semantic interoperability, that means the two devices, one manufactured by manufacturer A, must be able to understand the other one. It's called semantic. And you know, in computers we have syntax and semantic. Semantic is all about meaning. In fact, we have a port called semantic web. And data sharing, autonomous agents, these are all the different research areas which are open for any researcher who would like to pursue. And the last one, actually, lightweight and open middleware. Lightweight means, since IoT devices are always in short of memory and other computing devices, you should develop algorithms and mechanisms or software which take less computing power, less storage device, so that they can work. It is like, see, you cannot have a very high loaded encryption or decryption problem. You have to have something which is lightweight. Although we want to delegate our activities to devices through IoT, there are occasions where actually you want to bring in people to that location. For example, if you are doing an IoT application in a medical, somewhere you have to bring the nurse, the healthing staff, or a doctor. So this is called actually humans in the loop. That means after a certain level, you need to include people into this network. Let us see an example. A car designed incorporating human in the loop design approach can improve safety. Okay. Then if you devise a car only including IoT devices which will manage everything, then that would lose the charm. Nobody will start using that. So you have to include that human because he is the person who is going to drive. IoT can assist him and it will help him, but it cannot take complete control. So the aspect of including a man is actually called humans in the loop. So other things which include like software for the virtualization, energy efficient micro operating systems, algorithms for optimal assignment. You know, optimizing whatever the limited resources is a big thing. We have operating systems to ensure that in a computer, but we need that kind of a mechanism in IoT devices for whatever the resource care IoT devices must be managed. For that we need this one. Finally, not finally, next actually we need hardware. See, today we are used to only this kind of a hardware, a processor and a screen and a mouse and a printer or a server. But in IoT, everything is a hardware. Any additional device that you add is a hardware. Now you have to design hardware in such a fashion that they are energy efficient, they are compatible with other devices, they can communicate with others. So development in the IoT will require research in the hardware adoption. So that means if I add one IoT device, how does actually it becomes compatible with the rest of the system? Today we have this USB, right? Universal Serious Bus. So that means you can use the same port to include, connect your mouse or your pen drive or any other device. This kind of a portability we should get in every device that we are going to add. And secondly, we need a hardware which is programmable, but it should be at a lower level. And context switching awareness, architecture. That means there are changes. IoT devices are installed for sensing. If there is a day and a night, or if there is a warm day and a cold day, they should be positioned to context. The context. And there is also an idea of context awareness program where the local parameters are actually collected. For example, as soon as you enter your house, depending on what your taste and all, TV will actually automatically change the channel. So this is actually called context-aware programming or context-aware approaches. And we need research for the scalable cognitive hardware system. Cognitive is actually all about intelligence. Today we have a very dumb, very passive hardware. It will do what you have told it to do, for example. But it is possible that we build a little kind of artificial intelligence and make them cognitive. Cognitive is ability to understand your environment. And self-adaptive networks. This is actually happens in internet. If there is a power down, if there is a kind of attack on a network and all, over a period of time actually the network will come back to its original status. It's called resilience. So the ability of this is actually called self-adaptive networks. What are the issues? Which is open for any researcher. Nanotechnologies, how miniaturization, that means making things smaller and smaller. Polymer electronics. Polymer is actually a chemical science which is trying to develop some applications or some materials which can be used for developing IoT applications. Embedded systems, low cost, high performance, secure identification and authentication devices, low cost manufacturing techniques. These are all in concern with making it efficient, economically acceptable, and so on. Tamper-resistant technology. That means most of the devices I told you, they are in the public. For example, any IoT device which is there in the traffic system, which is available and accessible for open public. Now, how do you ensure that it is tamper-resistant? Suppose somebody monitors a particular traffic accident and all. How do you ensure that the data collected by that camera, IoT camera, is actually not tampered when it is presented in a court dispute? The next one is actually data and signal processing. This is very fairly simple. See, lot of data is actually collected because of the sensing mechanism. Similarly, a lot of signals are covered because we need wireless network and all. How do I manage at the edge is a big question. And this is what the research areas are. Research areas in the signal processing is actually semantic interoperability, service discovery, okay, semantic sensor, web and data sharing, propagation and collaboration. That means the data that I collect in a particular device planted on a patient, how does it actually propagate through the network and reaches the doctor or the hospital or the caretaker? Machine interaction, how does the sensor talk to a computer, which in turn will talk to another sensor? And next is actually discovery of search engine. I told you today Google is thriving because there are a lot of information available on the net. Similarly, a day will come when IoT device will have such a number that collecting information, organizing them will become a new proposition or a new challenge or a new business altogether. That today actually Google says it is organizing world's information. Maybe there will be a chance for another company which will organize world's IoT information about IoT devices. Okay. So any question at this point of time? Sridhar?
Yes, sir.
Anything here?
What natural objects can be connected to IoT?
So actually in agriculture and all, for example, even a plant is actually connected to IoT because what it actually measures some features like its greenness or its the humidity which actually it has. Or even in zoology and all, actually animals are actually used as a part of this tracking and all. And even a patient can be connected to a network by identifying. So by natural things, what we mean is actually there are things like plants, animals, and living things who can be mapped. It's not that we convert him into an IoT, but we'll implement an IoT or connect an IoT on him so that we can monitor either the animal or the plant or the vegetation or the animal husbandry aspect of that. Yeah.
Why do we have dependency on existing network? Why not we have self-created network?
Yeah, see, there's a big challenge. See, what I see, it is very ideal that we will develop a new network for IoT only. But you know, it is very expensive and it is very huge. So we normally depend on an existing infrastructure to develop the next one. See, for example, when internet started coming, we used the existing telephones, right? Now we are improving our telephone lines. So similarly, whenever we wanted to build a highway and all, we actually use the existing roads. Okay. It is ideally good that you develop your own network for IoT, but that's not going to happen in practice for a simple reason that it needs a huge investment. It needs involvement of so many countries, so many governments, so many organizations. That will not happen. That's the reason why I use existing, and it's very pragmatic, very practical, and very sensible approach to build on whatever is available today. So we built internet based on existing telephone lines. Similarly, we are building IoT on the existing internet. That means we have telephones above that internet and above that IoT. The whole idea is that.
What is spintronics?
What is that?
Spintronics.
Oh, spintronics, actually, see, you know that every atom has an electron, and actually they have a spin. That means left, right, actually they move. Okay. So this spin is actually used in quantum mechanics. Right? So now you can use this feature in some of the IoT applications. Spin is actually the movement of an electron or an atomic element in different directions. Okay. So that is used in this. This is called spintronics.
No more questions, sir.
We'll move on.
Yes, sir.
Okay. So discovery technologies, I told you, today we have Google or Yahoo for searching people and information. Tomorrow we have a search engine to search IoT and their density, their population, their demography and all other things. These services play a key role in mapping between real entities. For example, there is an IoT which is connected to an individual who is real. There is an application which is real in nature. Now these service technologies will help us to connect. Say for example, today suppose you want to book a Ola taxi. So now you are real, but taxi is a non-living thing, right? Similarly, tomorrow it may happen that an IoT device will send a request to a real thing, a real person seeking a service from him or service from her. So that is called mapping. Universal authentication, that means you must be in a position to use whatever the service available, whether it is in India or elsewhere. For efficient search and discovery, now actually no. Until Google came, searching was a big problem. Things like Yahoo and all, they had search engines of their own, but they were not efficient. So developing an application, a search engine or a search mechanism needs to be very efficient. Now IoTs are actually installed in different locations. Since they are geographically positioned, you must be also in a position to include the spatial data into that. It's not just the HTML text or a location or an IP address, the spatial data, that is what is included in this particular thing. So in this, these are the research areas. Device discovery, that means today actually I can go to Google and say, is there any PDF document in the world which is hosted on the internet today? It will search and give you. Is there any person by this name? It will give you, like in LinkedIn and all. Similarly, there may be an occasion in which you ask, is there any this particular device with this number available or connected to internet anywhere? Today it's like asking whether this phone number exists or not. Okay. Positioning in localization. That means I suppose, for example, today it is possible that the location of the phone can be found out using a GPS. Similarly, an IoT device location should be in a position to be identified. And mapping into real. Can I say that this particular phone is in Bangalore and this belongs to a particular person who is the owner of that? Can I find out whether this vehicle, where is it currently located and whom does it belong to? Similarly, an IoT device can be mapped to the real entity. The next one is actually relationship. What it actually means this is a higher level of relationship. Now that many networks are there, how do they connect? For example, in a computer network, two computers are connected to a LAN, which in turn connected to a WAN, which in turn connected to an internet. So this kind of a relationship also to be managed in terms of connecting devices. One device belongs to a local network of IoT devices, which in turn belongs to that institution, which in turn belongs to the society of that organization, and that. So that comes under the relationship network management. And here the research issues are propagation of MEMS by things. MEMS is actually mechanical electronic device which has a mechanical component, electronic component and a sensor. Identify relationship and reputation management. For example, today actually by looking at the phone number you can say that this is a Vodafone number, this is a Docomo number. So similar kind of a service should be available where actually looking at the IP or a number of a particular IoT, you should be in a position to say that this belongs to this manufacturer, this belongs to this particular country, and so on. And the next one is power and energy storage. You know, they need a power and they need lot of power. And how do I manage that one? The research issues which are there in this are this energy harvesting and scavenging for MEMS devices and microsystem. So now that I cannot have an independent source, power source for a particular device, can it scavenge from the environment? Can it actually collect it from the environment? Like say if there are 10 computers or 10 power stations, power poles and all, is it possible that it can capture that? That is an area which is actually happening. Micro combustion engines, these are the things that people within the field like electronics, electrical will understand. And finally, not exactly finally, not before that, security and privacy issues. If you want IoT to prosper and succeed, you should develop confidence of people to participate in that. The people confidence will only come when actually they trust your systems. So building regular services for that is requirement. So what we have to develop is confidentiality and authenticity. Confidentiality, that means whatever that I share is required and needed will and go to only to person. For example, if I put my marks or my medical information, it should reach only the concerned doctor. Authenticity, it is the right person who has actually have access and doing this. So in order to, these are the issues in the security, event-driven agents. That means if somebody touches an IoT, I should get an alert. If somebody tampers it, I should get an alert. And all these models for decentralized authentication, legal and liability issues. For example, if you publish something which is unwanted or which is dangerous on a Facebook today, police will catch you, right? Because there are rules which, so that means there is a way to authenticate that you are the person who published that data. Similar, that kind of a thing should be associated with this one. And other things like access and user rights. Suppose you create a data today on the internet, like creating a blog and all, copyright belongs to you. Similarly, suppose your IoT device creates it, who will have the ownership? That has to be answered. Integration information into connection. That means whatever it is generated should go to an application like MS Word, or it should go to an Excel sheet. So interaction time. Any questions? Sridhar, any questions?
Yes, sir.
Yeah.
Can any smart object itself play the role of search engine?
Yes. See, object is like, search, object, if it is an IoT, then it is a device capable of doing certain thing. So if it is big enough, then actually it can search itself, because that kind of a mechanism can be built into that. So but while it is searching, probably the search area is limited. For example, an IoT device can search its environment. See, for example, you know the example of this Bluetooth technology, right? See, suppose my mobile is capable of Bluetooth technology, and if your mobile is also there, then Bluetooth technology, my mobile will automatically detect the existing another device. So this is automatic, okay? But that doesn't search the entire network in the world. Similarly, an object, if it is capable like Bluetooth technology, can search the surrounding environment or information on its own. Yes.
If a person speaks a sentence to search something in Google, as done in Android phones, can this concept be termed as IoT?
No, because see, this is a human involved is actually doing. No, like companies like Apple have something application called Siri and all, where actually you speak and based on what you spoke, it will search for you. So this is not an IoT because there is no device involved in it. It's a human agent asking a search engine.
Will search engine be in the form of IoT itself, that is a population of autonomous IoT objects?
Yeah, yes, sir. That's what it is actually. See, when we are talking about search and discovery, so that search engine will discover only IoT devices. IoT is not going to search any other digital information like that. But they can be combined. But the main objective of what is the population of IoT devices? What is the demography? Like you can say like how many of them are in India, how many of them are in Australia, this kind. So the basic element of this search engine is IoT device, not people or other information.
Can a wireless sensor network be considered to be IoT?
No, wireless sensor network is an infrastructure to which actually you add an IoT. So that means it's a network, it's an infrastructure. Wireless network is an infrastructure to which actually you can connect one of the IoT devices. Yeah.
So only
It's
physical.
like connecting a computer to. It's like connecting a computer to internet. Okay, computer is not network, but it is connected to internet. Similarly, internet is not computer, but it is the infrastructure which allows a computer to be connected to it. Yeah.
So only physical devices which interact is IoT. Am I right?
No, sir. Actually, anything, and that could be a living thing. I told you, no. So you can actually make a plant to share its information with the biologist or a zoologist. Okay. So what IoT does is actually it will enable me to communicate or talk or collect information from different locations, which today is possible only I physically go there and get it. So when I say device, 90% it is a physical device, but it could be also intelligent and a living device. Yes.
Can we apply big data in IoT?
Yes, actually it is coming shortly in the next slide and all. Okay, I will tell you. Because sensors collect lot of data it becomes a big proposition to manage that data. And that data needs a lot of both processing and power. Okay, that becomes a part of the IoT. Another 2 or 3 slides I will come to that, because these are the different challenges which face, and they are opening. I mean, they are also a part of this IoT. Yes, sir.
Yes, sir. Continue, sir. We will continue the questions after that.
Okay, okay. So the final one is actually standardization. Let me go a little fast because I have another 5 minutes to finish. Okay, standardization. So standardization is a process which started with Industrial Revolution. What actually, if I want to use some other manufacturer's component, it was not possible in the earlier days because they have to have different kind of a standard, different kind of a parameters and all. For example, I cannot borrow a Philips bulb and put it in my holder because it is a different kind of a screwing or a threading. But today industry has worked in such a fashion that there is a standardization. Any USB port can take any mobile, I mean any mouse. Similarly, any pen drive can go to any machine. Why? There is a standardization done. Similarly, in IoT, we need the standardization. So that we are working. And the challenges in the standardizations are this. IoT standardization means 2 IoT devices must have standards, protocols, and other things that can talk to each other, like how a mouse can be connected to any laptop anywhere in the world, because the moment you say, it displays a message saying that a new device is added. Similarly, the moment you add a pen drive, it says it is added. Why? It has a standardization. So these are the different questions which are in areas where actually standardization is happening. Okay, so security and privacy have these things. Data confidentiality, what I have told, only should stay with you. That's confidentiality. Privacy, what I have told you should not be disclosed to the rest of the world. That is privacy. And trust, I believe in you. So I will come back to this area of somebody has asked me a question. So the additional research areas will include the massive scaling. See, the second one is creating knowledge and big data. So massive scaling, that if I want more and more addresses, IP4 will not support, IP6 I will go. So that's called massive scaling. So this is where the answer to the other person is there. See, in IoT world, there exists a vast amount of raw data being continuously collected. Sensors will collect lot many data, and devices will generate lot many data. So now this is to be taken care, and this is where actually big data will come. Somebody asked me this question, big data is connected to IoT very much. Look at this. In a medical area, new streams of sensor values must be converted into semantically meaningful activities. See, a hospital like Manipal or a big hospital, it will keep collecting lot of data from different patients. But this stream of continuous data must be converted into something of a meaningful called semantic. In that case, to store that data, to process that data, and to convert that data into some kind of a sensible information, I use big data idea. So in a sense, IoT depends on big data if it generates lot of data. Robustness, that means, see, one thing about these IoTs, actually they are spread in the open nature. See, an IoT device which is installed in a jungle or an animal or in a stadium is actually subject to harsh weather conditions and all. They should be able to actually take care of that one. So openness, I already told you. So this is the conclusion. The conclusion is IoT is a new found land. That means like the 17th or 16th century people found America, Jamaica, and India and all. So it's a newfound area, newfound land. So it needs an opportunity. It is an opportunity for us. Research is already underway to take care of this. So anybody, any academician or any research organization can take on this one. And my upcoming next session will be on every country, every major country in the world is actually started taking some steps towards IoT. So India is not lagging behind. It has just published its draft document on the website, the Department of Electronics and Information Technology. So that I will be discussing in my next presentation. So this is my contact information. These are the references which are there for today's this one. So any questions you can ask? Yes, sir. Sridhar, I have come to the end of my presentation.
Yes, sir. By and large, the 12 issues discussed so far, so far look like extension of existing problems rather than completely new research challenges.
No, they are all new challenges because new dimensions, right? So, for example, when you start mobile devices in compared to the status traditional, it is an extension of a communication problem. but it's a mobile problem, right? So it's an extension. Similarly, see, when you are actually start building roads on a hilly terrain, it's an extension of building the roads, but you are building in a very harsh condition like Himalayas and all. The problem is not new, the situation is new.
Does configuring special type of IoT become costlier?
What's that?
Does configuring special type of IoT become costlier?
Yes, see, actually, industry always works on what is called economics of scale. So if it is a very special purpose IoT, then it will cost you more because of the speciality only, right?
Does it mean that a WSN with at least one node connected to internet be IoT?
If that node is actually has a sensor, it's called MEMS. That means it should be a mechanical device or an electron device which is capable of storing data, sensing data, and perceiving the data, and if possible acting on data, then it actually becomes a IoT. A mere computer is not IoT, but a device which is capable of sensing, storing, processing, actuating, sharing, communicating with other devices actually becomes an IoT.
In case of scalability, how IoT smart objects control?
Okay, see, smart objects, see, I make a dumb thing into a smart object by actually adding some kind of a capabilities in terms of collecting information, making decisions, and processing that information and making decisions. So when you have scalability, then what actually happens is actually those tiny smart devices are capable of taking some information and sharing with others. See, if you know this network technology, we have what is known as hopping tables, right? So that means my information which is sent on internet to America, which actually go through the internet through this idea of this hopping technology, hopping tables, which will tell me what is the next node I should go, which is the next network I should enter. So hopping technology, hopping the tables act as intelligent centers which share information regarding the existing technology and also giving my direction for my travel. Similar, these smart objects probably will give you some information so that an IoT device can use that information to either communicate or share or duplicate or process that information.
Please suggest a good topic of research of big data in IoT.
I will do that, sir. Actually, send me an email to this and I will do that because I'm a little constrained on time. I have a meeting coming at 4:30.
Sure, sir. So I will send you there are 2-3 questions. I will send by email, sir.
Thank you very much, Sridhar. Thank you very much for the audience for the active participation. I'll get back to you. Thank you.
Thank you, sir.